All right, let's get into it. We're going to peel back the layers on one of the most powerful and maybe a little mysterious features in modern web development, React hooks. You've probably heard this one floating around, right? React hooks are just arrays. And look, it's a great starting point, a really helpful way to think about it, but it's not the whole story, not even close. So, this is the real head scratcher we're tackling today. Think about it. When your component re-renders, the whole function gets called again from scratch. So how in the world does useState just magically remember the value from last time? Normally, variables inside a function, they just disappear when the function is done. Hooks seem to completely break this fundamental rule of JavaScript. How can a function have a memory? And the answer, funny enough, is hiding right under our noses. It's baked into the very rules the React team tells us to follow. These aren't just annoying restrictions, they are the breadcrumbs that lead us straight to the truth. And the most important clue of all, it's that unbreakable rule about call order. This is the big one. You can't put hooks in an if statement, you can't put them in a loop. It's so critical that the React team built a linter, a tool that yells at you if you get it wrong. And that's because this isn't just a best practice, it is the absolute key to the entire mechanism. Okay, so because of that strict ordering, React can do something pretty clever to track state. Let's visualize this with that popular array model everyone talks about. Check this out. The first time your component renders, React says, okay, first useState call, you get index 0 in my secret array. The useEffect call, you're index 1. The second useState, index 2 for you. Then, on the next render, since the order is the exact same, React just goes, okay, first useState call, let me just look at index 0 again. It's totally predictable. It's deterministic. Now that array model is a fantastic way to wrap your head around the logic. It's brilliant, but it's time to pull back the curtain. That's not actually what's happening under the hood. To see the real story, we have to look inside the React engine itself. To really get it, we need to talk about React's core architecture. And that means diving into something called the fiber reconciler. So every single component you write has this internal JavaScript object associated with it called a fiber node. You can think of it like the component's private backpack, or its luggage. It carries all its important stuff. And the most important piece of luggage for us, the one we really care about, is this property right here, memomized state. And here it is, the big reveal. We've been thinking in terms of arrays this whole time, but what React actually uses is a singly linked list. Each hook you call creates a new node in that list. And that memorized state property on the fiber, it just points to the very first hook in the chain. Seriously, it's just like a conga line. Each hook object holds its own state, and then it has a next pointer that grabs onto the next hook in line, forming this chain that's attached to the component's fiber. So you might be asking, wait a minute, why a linked list? Aren't arrays faster? And for some things, sure. But for what React needs to do, which is constantly clone and update things behind the scenes, flexibility is king. With a linked list, it's super cheap and efficient to just add a new node to the end or clone parts of the chain. You don't have to reallocate a whole new giant block of memory like you might with an array. Now, this wasn't some random choice. It was a very, very deliberate design decision. And to see just how clever it is, let's look at another idea that a lot of people suggest, one that the React team thought about and decided against. Why not just use keys? You know, something like useState with a string, like name. That seems like it would solve the call order problem, right? You could finally put hooks inside if statements. But as Dan Abramov from the React team has explained, this would actually create way worse problem. Oh man, it would open up a huge can of worms. You'd have different custom hooks accidentally using the same key and overwriting each other's state. You'd get these weird situations where two hooks use the same underlying hook and they start sharing state when they shouldn't. The current system, with its strict call order, guarantees that every single hook call gets its own private, isolated little memory cell. It's what makes custom hooks so robust and easy to share. So that's the key takeaway. What feels like magic is actually just a beautiful piece of engineering. It's this well-coordinated dance between pointers and a linked list, a system that always knows which component is rendering, and all of it is held together by that simple, clever rule about call order. So what's the point? What does knowing all this actually change for you? Well, once you understand the why behind the rules, you start using hooks more effectively. You can debug things way more easily because you can picture that linked list in your head. And honestly, you just get this deeper appreciation for the elegant design that makes modern React so powerful. The magic is gone, and what's left is something even better, a rock-solid mental model.